Hypothesis. A hypothesis is a statement made on the basis of supposition. It is necessary to verify the hypothesis by relevant data. The hypothesis gives you the direction about the nature of data to be collected for verification. Example, it is a general belief that in cricket matches our spinners are more effective than our pacers. Here spinners mean the persons who bowl at slow speed and spin the ball in the air. Here pacers mean the persons who bowl at a very high speed. This statement is a hypothesis. It needs to be verified by relevant data. The data is as below. Name of person, type of bowling, overs bowled, runs given away, wickets taken. Praful Gandhi, fast pacer, 30, 180, 1. Sumit Khanna, fast pacer, 30, 200, 1. Sunil Arora, fast pacer, 30, 225, 1. Madan Malik, slow spinner, 30, 100, 3. Nikhil Mann, slow spinner, 30, 120, 2. Ravi Lal, slow spinner, 30, 110, 2. From the data we find the following informations. Pacers took 3 wickets and spinners took 7 wickets. So spinners took more wickets than pacers. Hence spinners are more effective in a cricket match. The hypothesis is verified. Why do we need data? Data are useful for the following purpose. A. For information. B. To maintain records. C. To verify hypothesis. D. Helps us to make some definite conclusions. Collecting and organizing data. We must know the objective of collecting data, which means for what purpose we are collecting data. Once we ensure the objective, we should start to collect the data in a very planned and systematic manner. When data is collected for a large group, it becomes difficult to write the entire data in a single column. Here we make use of a term called frequency. The word frequency means commonness of recurrence. The number of times a particular thing occurs in a data is called its frequency. When the number of observations is large, there is always a possibility of missing some observations. To minimize the number of errors and to make tabulation easier, we make use of tally marks. Tally marks. Vertical lines are used as symbol for counting the number of times a particular value repeats. They are written in group of 5. Example, 3 vertical lines represent 3. 4 vertical lines crossed by 1 diagonal line represent 5, one group. Instead of writing 30, we write first, second, third, fourth, fifth, sixth group. At a glance, you can make out 6 groups representing the number 30. Example 1. In a cricket match there are 11 players. Runs scored by first player is 20, second player 31, third player 25, fourth player 45, fifth player 65, sixth player 75, seventh player 45, eighth player 19, ninth player 10, 10th player 5, and the last player 2. When we represent the data as above, it looks a little confusing. But when we put the data in tabular form, it looks much more clear and easier to understand. Tabular form for above data. Player runs scored 1, 20, 2, 31, 3, 25, 4, 45, 5, 65, 6, 75, 7, 45, 8, 19, 9, 10, 10, 5, 11, 2. The representation of data is neat, clear and easy to understand. Example 2. In a class, the strength is 60. An ice cream company made a survey to find out the most popular variety of ice cream among students. Their findings are as follows. Ice cream variety. Tally marks. Frequency number of students. Vanilla. 7. chocolate. 10. Strawberry. 6. Butterscotch. 25. Cookie crumb. 12. The survey has been carried out among large group of 60 students and is written as tally marks. We find that the most liked variety of ice cream is butterscotch and most unpopular variety is strawberry. The above table is called frequency table. Representation of data. So far we have learnt how to collect data and how to organize them with the use of tabular form/frequency table. To represent the numerical data, we can draw graphs for these data. These can be done in many ways, but most popular ways of representation is pictograph. Pictograph. A pictograph is a way of representing data using pictures. You can use a suitable scale if the data is of large numbers. Example 1. In a botanical garden, there are many trees and they are in large numbers. There are 150 banana trees, 75 neem trees, 60 pine trees, 45 eucalyptus trees, and 30 palm trees. This can be represented by a pictograph. Banana tree, neem tree, pine tree, eucalyptus tree, palm tree. Scale is equal to 1 tree in each variety represents 15 trees. Answer the following questions. A. Which type of trees are maximum? B. Which type of trees are least? C. How many varieties of trees are more than 50? Solution. A. Banana trees. B. Palm trees. C. There are 3 varieties of trees more than 50. Example 2. In a parking area of Rajiv Chowk, Delhi cars parked on a particular day are given below. Maruti, Hyundai, Tata, SUV, Toyota, Nissan. Scale, image of 1 car, is equal to 10 cars. Find out the number of each variety of cars and the total number of cars parked at Rajiv Chowk, Delhi. Maruti, 1 car representing 10 cars. Total number of cars, 10. Multiply 10, 100. Hyundai, 1 car representing 10 cars. Total number of cars, 7. Multiply 10, 70. Tata, 1 car representing 10 cars. Total number of cars, 5. Multiply 10, 50. SUV, 1 car representing 10 cars. Total number of cars, 8. Multiply 10, 80. Toyota, 1 car representing 10 cars. Total number of cars, 5. Multiply 10, 50. Nissan, 1 car representing 10 cars. Total number of cars, 3. Multiply 10, 30. Total numbers of cars parked in parking area 380. Representation of data. So far we have learnt how to collect data and how to organize them with the use of tabular form/frequency table. To represent the numerical data, we can draw graphs for these data. These can be done in many ways, but most popular ways of representation is pictograph. Pictograph. A pictograph is a way of representing data using pictures. You can use a suitable scale if the data is of large numbers. Example 1. In a botanical garden, there are many trees and they are in large numbers. There are 150 banana trees, 75 neem trees, 60 pine trees, 45 eucalyptus trees, and 30 palm trees. This can be represented by a pictograph. Banana tree, neem tree, pine tree, eucalyptus tree, palm tree. Scale is equal to 1 tree in each variety represents 15 trees. Answer the following questions. A. Which type of trees are maximum? B. Which type of trees are least? C. How many varieties of trees are more than 50? Solution. A. Banana trees. B. Palm trees. C. There are 3 varieties of trees more than 50. Example 2. In a parking area of Rajiv Chowk, Delhi cars parked on a particular day are given below. Maruti, Hyundai, Tata, SUV, Toyota, Nissan. Scale image of 1 car is equal to 10 cars. Find out the number of each variety of cars and the total number of cars parked at Rajiv Chowk, Delhi. Maruti, 1 car representing 10 cars. Total number of cars, 10. Multiply 10. 100. Hyundai, 1 car representing 10 cars. Total number of cars, 7. Multiply 10. 70. Tata, 1 car representing 10 cars. Total number of cars, 5. Multiply 10. 50. SUV, 1 car representing 10 cars. Total number of cars, 8. Multiply 10. 80. Toyota, 1 car representing 10 cars. Total number of cars, 5. Multiply 10. 50. Nissan, 1 car representing 10 cars. Total number of cars, 3. Multiply 10. 30. Total numbers of cars parked in parking area, 380.